Hello everyone, from Surveying Group News. We are continue our interviews with Michael from RIEGL. Hello Michael, welcome.
Hello, how are you? Thank you. Welcome to the RIEGL booth.
As a refresher for our audiences, would you please explain what is the main benefits of using the airborne technologies? Because the aircraft and the LiDAR, two powerful components coming together, and what is the main benefit of this technology?
The primary benefit of using LiDAR technology is it is an active sensor. So we are sending out an energy source, which allows us to collect information both day or night. So we do not require ambient sunlight conditions to make those measurements. They are high precision instrumentation, so RIEGL's focus is on survey grade measurement technology using lasers. We combine the lasers with a programmable scanner and with inertial technology, so understanding the attitude of the platform, but also with the GPS component, we can put those points spatially on the Earth. So we generate high precision point clouds in a very productive manner from fast-moving platforms over the Earth. The other advantage with LiDAR is it can penetrate through forested canopies to allow us to detect the ground underneath those canopies, unlike, say, a photo. So we're able to basically create a very detailed structural information from the point cloud underneath these complex environments such as forested areas. We have a couple brand new product releases. This is the new VQ1260. This particular product allows us to collect up to 2.2 megahertz or 2.2 million shots a second. This is in a form factor that supports a gyro-stabilized mount, and we have actually transitioned to using onboard data storage, so we no longer need any external data recorders. So it's a much more compact installation in the aircraft environment. To my left, we also have the VQ1460. This sensor is very similar in format to the one on my right. The difference is we now add an extra module and we're able to double the point density up to 4.4 million shots per second. Inside the sensor cone is a brand new optical front end that also includes two medium format cameras. So we can collect both LiDAR and imagery simultaneously. Also in the airborne segment, we have a couple other releases that are focused more on the small to mid area mapping segment. This is the new VQ580 Mark IIS, and this allows us to collect LiDAR data, whether it's in an aircraft or in a wing pod, up to about 2.5 kilometers. And so this sensor is very capable of being integrated with third-party inertial systems, third-party flight management systems to build a custom solution, or we can offer this sensor from the factory as a turnkey system with all those components provided. This is in fact a terrestrial sensor, so it uses a 1 micron laser to be able to measure the terrain. To my right is the VQ840GL. This is a lightweight version of our earlier VQ840G sensor, and it's focused primarily on topo bathymetric data collection. So the enabling wavelength in that sensor is a green laser, which allows us to penetrate the water column and be able to obtain depth information. The advantage of collecting the topobathy information using LiDAR is the productivity or the efficiency of collection of that depth information from a fast-moving platform. This particular sensor has been redesigned to have a lightweight cover. We've removed some of the internal components to allow it to also be installed on some heavy lift drone platforms as well. Also in the drone space is a new sensor called the VUX 160. So this particular sensor is primarily focused for our drone platforms, but because of the new range performance of this sensor, it's also capable of being installed on a helicopter or a low-flying aircraft. What's unique about this particular product, it actually has a tri-axis geometry, which allows the laser, with a single rotation of the scanner, to operate and collect information 10 degrees forward at nadir and 10 degrees backwards. And so as we overfly the terrain, we're able to improve the vertical density and get much more resolution on vertical structures as we fly. This particular sensor is often combined in our helicopter platforms with additional cameras to provide a hybrid mapping solution. And finally, this is the new RIEGL VZ600i terrestrial scanner. This is a next generation design which features our standard onboard scan registration, which is extremely popular. We've significantly reduced the weight and the size of the scanner over the previous generation, and it also includes the ability to simultaneously collect both imagery and LiDAR in a single rotation. And that single rotation speed can vary anywhere from 2 to 30 seconds. So it's quite fast, it provides very accurate data, and it is much more lightweight and compact to use. In addition to that, this particular sensor also includes the ability to add a DMI, a distance measurement indicator, to be able to be also considered for kinematic use. So we can install this sensor on a moving platform as well as a tripod, so it provides a much more diversity of application for those that are looking for a sensor that can do a multiple of different types of jobs.
Thank you.
Thank you. It's our pleasure. I hope you enjoy the show and enjoy your day.